Okay, so for this part of the lesson, we're going to talk about not only the concept of reactions gaining and losing electrons, but combining that with this idea that if you add up all of the charges on the parts of the atoms, it gives you an overall charge to the atom. So if we're looking at our learning goals, we're right here where it says describe how the charges on these parts lead to the overall charge of the atom, and then we'll move into the second part, which is describe how changing the number of electrons can change the overall charge of an atom. So let's go back here to this picture that we've looked at in previous video clips, and let's look at it a little bit more closely. And let me get my pen tool ready here. Okay, so let's count up the charges for just this atom right here. So it looks like we've got 3 neutrons, but they have no charge. So the neutrons really don't matter when we're talking about charges. But if we look at protons, we've got 1, 2, 3, and each proton has a plus charge. So that means for the protons, we would have plus 3. Now let's count for the electrons. We'd have 1, 2, 3. Each one has a negative charge. So if we're going to look at electrons, we have minus 3. And so to get the total, we simply add them up. We have 3 positives, 3 negatives, plus 3, minus 3. The total charge on this atom is 0. Okay, but now let's see what happens to this atom after it reacts. So let's remind you about reaction. Reaction, atoms are going to react when their valence shells are either completely full, or not completely full, or not completely empty. So we already said if we looked at this first valence shell, we've got 1, 2 electrons. Okay, that one's completely full. But this second valence shell here, we've only got 1 electron. It can hold 8, therefore it's unstable. And we said the way it reacts is it loses that electron, because it's easier to lose 1 than it is to gain 7. Okay, so let's count up again to see what the overall charge is. So overall charge, 1, 2, 3 protons, so we still have plus 3. But now let's count our electrons. We've got 1, 2, so that's going to be minus 2. And so what is 3 minus 2? Well, that leaves you with a positive 1. Okay? And so once we react and lose an electron, that changes the overall charge on this atom. Now for vocabulary words, you should know that if an atom has a charge, it is called an ion. Okay? All right, so let's look here at another example. So if you remind yourself by looking on the chart, a sodium atom, because it's sodium, we're going to know how many protons it has. So a sodium atom here for protons is going to have 11 protons. So we're going to have plus 11. And now let's count our electrons. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we've got 11 negative charges. Our overall charge on this will be 0. Okay? But is this stable? Well, let's look. The first valence shell has 2 electrons, so first shell is stable. The second one has 8, so second shell is stable. Third shell has 1. If you need to remind yourself by looking on the notes, we can know that to be stable, that third shell either has to have 0 or 8. It's got 1. So it either has to gain 7 or lose 1. It's easier to lose that 1. And so now it becomes an ion. It loses that electron. And so we've changed things. So we haven't lost protons. Remember, it's still sodium. We only lose electrons, so we still have 11 positive charges. But now we've lost 1 electron, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So we've only got 10 negative charges. So that gives us an overall charge of positive 1, which sometimes you'll just see representative with only a positive sign here. Okay? Because it's charged, it is called an ion. Okay? So if you see an ion, this is a rule that might be helpful. If you see an ion that has a positive charge, that means that it has lost electrons. It has more protons than electrons, so it had to lose electrons. Okay, so now let's erase the ink here, and now let's look at a different atom. Okay, so chloride here. Okay, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 electrons here. So we have a minus 17 charge. Okay, we know because it's chloride or chlorine that it is going to have 17 protons. So that gives this atom a total charge of 0, because 17 minus 17 is 0. But let's ask ourselves, is it stable? First shell has 2 electrons. Yes, it's stable. Second shell's got 8. Maximum it can hold is 8, so yes, it's stable. But the third shell has 7, and this thing here on the book, it is a little bit, students sometimes find it a little confusing. This is supposed to represent a place where an electron could be, but it is not. So only if it's yellow does that mean the electron is there. Okay, and so this third shell has 7 electrons, but what's the maximum it can hold? 8. So is it completely full? No. Is it completely empty? No. So it's unstable. So now we ask ourselves, it's got 7. Is it easier to gain 1 or lose 7? Well, it's easier to gain 1. So that's what it does. So let's look at what it is here. It's still chlorine, so we still have 17 protons. But now, over here we had 17 electrons, but now we've gained 1, so now we have 18 electrons. And so, 17 minus 18 gives us a negative 1. Okay, and so that's what this negative charge is over here. It's negative 1. This, even though the charge is negative, it is still called an ion. So an ion is any charged atom, okay, or any charged particle. Okay. If it is a positive charge, it is called a cation. You could think cat. If you're a cat lover, cats are a positive thing. So positive for cat. Positive for cation. An anion is a negatively charged ion. Okay. So let's go here to our notes and let's put in a few different things, or let's work through some problems here. It will be helpful. Okay. And so answer the following questions to help you understand the charge of an atom. So if it has one proton and one electron, the number of positive charges, remember, only protons are positive, and so +1, because it's got one proton. What are the number of negative charges? Well, it has one electron, so it's got a negative charge. So +1 -1, the total charge on the atom, 0. It has no charge, or you could say no charge. All right. Is the atom an ion? Well, ions have charges. Does this have a charge? No. So no. And then this next column says, if so, is the atom a cation or an anion? Well, it's not an ion, so it doesn't apply. Okay. It doesn't apply. Or you could put neither. Okay, let's do the next one. It has one proton, so we're still going to have a charge of +1. And 2 electrons. So how many negative charges do we have now? Well, we have 2, so that gives us a -2. So 1 minus 2, what's the total charge on the atom? A -1. Is the atom an ion? Well, it's got a charge, so yes. Is the atom a cation or an anion? Well, cations are positive charges, anions are negative, so it's going to be an anion because of the negative charge. Okay. And then I'll let you do this next section here about protons, or this next column right here for protons, and 3 protons and 1 electron. And see if you can get that one on your own. Feel free to email your instructor if you're unsure. Okay, let's also look up here. Okay, and this is another place where we can ask ourselves, how would an atom react? Okay, so an atom has 1 proton and 1 electron. Okay, well, so for reaction, do you even really have to worry about the protons? No, we're just going to look at the electrons to find out if those valence shells are full. If it helps, you may want to draw it. Okay. So the first valence shell holds 2 electrons. Can we fill it? No, we only have 1. So how would it react? It's either going to gain 1 electron or lose 1 electron. Okay, so for our purposes, they've seen that this is how it works. In most cases in this situation, it will actually lose 1 electron. Okay. So let's look at this one. An atom has 11 protons and 11 electrons. Again, how will it react? Which one do we care about? Just electrons. Electrons are what we care about with reactions. So let's go over here to this Word document and see if we can do it this way. So 11 electrons. So our first valence shell, maximum 2, and we can fill it. Fill to give 9 electrons left. Okay, so we had 11, we put the first 2 in that first shell, giving us 9 still. So where else are we going to put them? Okay, we've got to put them in the second valence shell next. So the second valence shell can hold a maximum of 9 electrons. So we can fill it because can hold a maximum of 8 electrons. Well, we've got 9 total left, and so we can fill to give 1 electron left over. Where are we going to put it? Third valence shell. The maximum is 8. We'll put 1 electron into this shell but can't fill it. So, atom is unstable. So, we can put 1 electron in it, but the maximum is 8. So we can either gain 7 or lose 1. So what are we going to do? Lose 1 electron. Okay, and so if we're going back over here to our notes, okay, lose 1 electron. Okay. And then again, I'm going to leave this last one for you to do to see if you can get it right, and feel free to email your instructor to see if you have gotten it right. Okay? All right. So, I believe that that is everything on this page. One point about nomenclature. Nomenclature is how are things written in chemical abbreviations or terms. Okay. So this is a situation where if you see the name of the atom, the abbreviation for the atom, so if you remember big C little a is calcium, and then in a superscript, right on the right side of that, it's got 2+. That's where the charge is. That means it's got 2 extra positive charges, but do we gain protons? No. We only gain or lose electrons, so that means that we have lost 2 electrons. Okay. All right, so this is a situation here where you can use your chart back on page 2 to let you know what is the atom. Remember, it's based on the number of protons. Okay. And then, once you figure that out, you can figure out, okay, based on the charge, how many electrons does that mean that it has? Okay? All right. So I believe that's everything for this section. Continue to use the activities here to test your knowledge and email your instructor if you're having problems.